I, Anand Jain from Hanumangarh, Rajasthan, welcomes you to Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subject. Today in our class 12th physics playlist, we'll understand resultant magnetic field of both straight and circular current carrying conductors. With a brief theory, we'll practice several configuration of straight and circular conductors and try to cover almost all probable exam questions. Next 20 minutes will definitely improve your conceptual clarity and confidence. Let's start. Magnetic field of a straight conductor carrying I current at a perpendicular distance r from it is given by this relation, where theta 1 dash and theta 2 dash are internal acute angle formed by limiting position of conductor length between current length and position vector joining observation position to extreme A and B condition of this conductor. In all these today's problem, our circular section could be full circle, half circle, quarter circle or 3/4 circle, but straight portion is always infinite conductor and observation positions lies at one end of it. So these two, theta 1 dash and theta 2 respectively, will become 0 and 90, and with value of cos 0 1 and cos 90 0, our magnetic field of an infinite long straight conductor carry I current at a perpendicular distance r at one of its extreme end become mu 0 I upon 4 pi r Tesla. With one full circle circular current and infinite long conductors, we have three question pattern, and in all three questions we have to find out resultant magnetic field at the center O of circular current section. Now in this first example, a infinite long straight conductor from A to B form a circular shape, and then with straight stretch it go to infinity to other side. To find out resultant magnetic field due to AB straight length, D straight length and BCD circular section, we have to first find out direction of three magnetic field contribution at this O point. From visual inspection, it looks that this O position is unclosed by current sections, so all magnetic contribution will add together. This can be checked by Maxwell right-hand rule. Now Maxwell right-hand rule can be applied to find out magnetic field of straight conductor as well as circular conductor. In right hand we have straight thumb and curved finger, and if current is straight, then this stretch straight thumb is the direction of current, and this curve of finger around this conductor represent the direction of magnetic field. And for this center O position which lies on top of it, this tip of finger at observation position indicate perpendicular to this plane towards us the magnetic field contribution of AB conductor as well as of D conductor. Thumb is in the direction of current and this tip of finger at observation position indicate magnetic field perpendicular to your screen towards you. And for this circular section, since current is curved, this curled finger will take orientation of curved current, and this thumb perpendicular to this coil plane indicate the direction of magnetic field. So all three magnetic field of AD straight conductor infinite length are perpendicular distance at one end is mu 0 I upon 4 pi r, and the second DE conductor when add with it become mu 0 I upon 2 pi r towards us, and this circular section produce magnetic field mu 0 I upon 2 r towards us. When we take LCM 2 pi r and brought mu 0 I common, this become pi times and this is 1. So our resultant magnetic field is mu 0 I upon 2 pi r pi plus 1. In this second example also we have to find out resultant magnetic field at the center of this circular section of radius r having two infinite length section as shown in figure. So current from A to B of infinite length take a circular shape BCD, and again D is a straight stretch of infinite length. Now this current is not making a single enclosure around this observation position. So if we see magnetic field of straight portion, they both are in the same direction add together, but the magnetic field of circle section is in opposite direction, and this finite 2 pi r length being it at a smaller distance position from observation position, and current element makes 90-degree angle with this circle center contribute much more than two infinite length section at two sides. First check the directions. For straight sections AB and DE, the thumb of right hand get aligned with direction of current, and tip of finger at this observation position indicate magnetic field perpendicular to this screen outward towards us, whereas for this circular current, when the fingers of right hand are curled in the direction of current, this thumb perpendicular to this plane indicate inward direction of magnetic field. As told earlier, this small BCD section of 2 pi r length produce much more magnetic field in downward direction than the two infinite length, as all these current elements acts with only r distance and with 90 degree angle between current element and distance vector, whereas this infinite length, only these length sections which are close to observation point contribute relatively more, and the remaining length won't contribute much, being at high distance position and angle very different from 90 degree. So this magnetic field of circular section is mu 0 I upon 2r inward, and magnetic these two infinite length at one end of each infinite length is mu 0 I upon 4 pi r, and the two become mu 0 I upon 2 pi r, and resultant magnetic field is simple difference of inward magnetic field of circular section and outward magnetic field of straight section, and it is mu 0 I upon 2 pi r multiplied by pi minus 1 Tesla, and it is inward in direction. In this third and last example of full circle current distribution, the plane of circle is tilted by an angle 90 degree as shown here, and these two infinite length AB and DE become a single infinite length with observation point O at its center, and they contribute magnetic field mu 0 I upon 2 pi r, and this circle produce magnetic field pi times more than this infinite length by a limited 2 pi r length as mu 0 I upon 2 r. Now the two direction of magnetic field of straight conductor and circular conductor are perpendicular to each other. That can be verified by Maxwell right-hand rule. Magnetic field of straight conductor with straight thumb in the direction of current is represented by tip of curled finger at observation position, and it is in coil plane perpendicular to current length as shown by this arrow direction, and its magnitude is mu 0 I upon 2 pi r. Whereas for circular section, when curled fingers are oriented in the direction of curved current in coil, this straight thumb perpendicular to this coil plane and parallel to conductor represent this direction of magnetic field. The resultant magnetic field of coil and straight conductor length can be obtained by Pythagoras calculations, as two magnetic field of coil and straight portion are perpendicular to each other. The resultant magnetic field can be obtained by Pythagoras calculation, and in place of coil magnetic field we can substitute mu 0 I upon 2 r, I current in circle and r radius, and for this infinite straight length at midpoint r distance position, resultant magnetic field is mu 0 I upon 2 pi r, and for Pythagoras calculation, when mu 0 I upon 2 pi r is brought as common out, this becomes square root of pi square plus 1 in Tesla unit. In all following examples, in place of full circle, we'll consider a partial circular current carrying length, and we have to find out its magnetic contribution at center position O. This can be explained by this simple example. An infinite straight A dash A length carry I current, and from A to B it form a circular arc of L length, and then again it went straight to infinity as B dash. Now here this observation position, center of this circular arc, lies on the axis of A dash A current and B dash current, and we know a straight current won't produce any magnetic field on its own axis, so here only this circular AB section will contribute resultant magnetic field. Now this AB section of arc length L subtend an angle theta in radian, and theta angle is given as arc by radius, and to find out resultant magnetic field contribution of AB arc length, let's take a elemental length dl, and that length contribute a elemental magnetic field as mu 0 I delta L sine 90 upon 4 pi r square, where r is radius of circular arc, as we have to find out magnetic field at its center, and 90 is angle between circumference of circular AB section and radius, that is 90. Now we can brought mu 0 I 4 pi and 1 r as common, and this becomes simply integration of arc length section divided by radius, and this is complete arc AB, and arc by radius is angle theta in radian. So in terms of angle subtended by arc section AB at center theta, we can write total magnetic contribution of I current and r radius is mu 0 I theta upon 4 pi r. Now to make relation easy to use and memorize, we can convert this in mu 0 I divided by 2r multiplied by numerator theta and denominator 2 pi, and this is quite handy relation to use, as mu 0 I upon 2r is magnetic field at a center of circle of radius r and carrying current I, and total circle make a total angle of 2 pi radian, so theta will produce proportional magnetic contribution as theta upon 2 pi times mu 0 I upon 2r. So resultant magnetic field of complete one circle of current I and radius r is mu 0 I upon 2r, and per unit angle it produce magnetic field divided by 2 pi radian. and theta angle will produce magnetic field mu 0 I theta upon 4 pi r. And if theta is given in degrees, then we can convert both radian theta and 2 pi radian angle, as 2 pi radian is 360 in degree angle format. And if our angle theta is full circle, then magnetic field at center by I current is mu 0 I upon 2r. If this is half of circle, semicircle, then angle is only pi radian, and magnetic field become half of full circle, mu 0 I upon 2r, when halved become mu 0 I upon 4r. And for 90 degree angle or pi by 2 radian angle, it become half of half, or mu 0 I upon 8r, 1/4 of full circle magnetic field. For pi by 3 or 60 degree, 1/6 of full circle angle, magnetic field become 1/6 of full circle magnetic field, mu 0 I upon 12r. And for 45 degree or pi by 4 radian angle, it become mu 0 I upon 16r. And for 3/4 circle, angle is 3 pi by 2, and our magnetic field is 3/4 of this figure, 3 mu 0 I upon 8r. So theta is how much fraction of complete circle angle. Accordingly, we will have magnetic field contribution of that circular arc. Let's start our practice with semicircle current configuration. Two straight infinite AB length and DE length with this semicircle are carrying I current, and we have to find out resultant magnetic field at center O position of this circular arc. Now here AB and DE infinite straight length are coaxial length with this observation position, so they won't contribute any magnetic field at this center position, and only circular arc will produce resultant magnetic field at this center O position. Now the full circle produce mu 0 I upon 2r Tesla magnetic field with I current and r radius, and half circle will produce half of it, so our resultant magnetic field is mu 0 I upon 4r. We know that as circular arc produce magnetic field perpendicular to current loop, so when thumb is put perpendicular to this circular current loop plane and finger of right hand got their matching curved orientation with current orientation, then this perpendicular to plane inward thumb direction will become straight magnetic field at the center position, mu 0 I upon 4r Tesla cross, means perpendicular and inward to screen plane. When previous example is modified with D length, which was earlier coaxial with O position, become perpendicular to it, and now this O point from this infinite length at one end with r perpendicular distance. AB length as earlier is coaxial to observation position, won't contribute magnetic field, and these two circular arc and straight infinite length make an enclosure with this O point, so both magnetic field will add together as checked by right hand rule. For semicircle BCD section, magnetic field perpendicular to this coil plane is indicated by perpendicular straight direction of thumb, as curled finger and current got identical alignment. And for straight conductor, when straight thumb is along current in conductor, this tip of curved finger at observation position indicate inward direction, so two inward magnetic field, mu 0 I upon 4r from semicircle and mu 0 I upon 4 pi r of straight infinite DE length are in the same direction perpendicular to this screen plane inward, and when mu 0 I upon 4 pi r is brought common, this is pi times and this is 1 times, so resultant magnetic field is pi plus 1 times of mu 0 I upon 4 pi r in inward direction. In this example, two current carrying infinite length AB and DE along with semicircle arc BCD make a complete enclosure around this observation position, so magnetic contribution of all those current will add together. This can be verified from Maxwell right hand rule. For straight portion, straight thumb will indicate direction of current, and for curved BCD circular section, curved finger of right hand represent the current direction, and magnetic field of straight current from tip of curved finger at this observation position indicate perpendicular to plane inward direction. For this BCD section, this straight thumb perpendicular to BCD section inward represent direction of magnetic field. Similarly, this straight current along which right hand thumb is there, this curved finger tip indicate perpendicular to plane inward direction of magnetic field. So all three magnetic field are in the same inward direction perpendicular to this plane. So resultant magnetic field at center O position is magnetic field contribution of AB conductor, which is mu 0 I upon 4 pi r for infinite straight length carry I current and r perpendicular distance of observation position. This BCD section produce half of mu 0 I upon 2r, that is mu 0 I upon 4r magnetic contribution, and this DE length produce again infinite length, extreme position r distance, mu 0 I upon 4 pi r magnitude. When mu 0 I upon 4 pi r is brought common, this is pi times, and these two 1 and 1 added together become 2. So the resultant magnetic field at center is mu 0 I upon 4 pi r multiplied by pi plus 2 Tesla, inward perpendicular to plane. Now in this example, observation point O, center of this semicircle BCD arc, is not on the axis of AB or DE conductor, but it got perpendicular r distance at one end of these conductor of infinite length carrying I current. So these two will contribute magnetic field along with this circular arc, and AB and BCD section make a identical enclosure around this O point, so their magnetic contribution are in the same direction, and this is reverse orientation of enclosure by D length, so its magnetic field is opposite to other two magnetic contribution, and magnetic contribution of AB length and DE length, equal and opposite, will cancel each other, and resultant magnetic field will become only magnetic field of semicircle BCD section of I current and R radius. Full circle produce mu 0 I upon 2R, so half circle will produce mu 0 I upon 4R Tesla magnetic field. Let's check the same with right hand rule. For AB and DE straight lengths, when thumb of right hand is along straight current, then the tip of curled finger for AB conductor at O produce inward magnetic field along the direction of magnetic field of BCD semicircle current, but this DE length produce magnetic field opposite in direction upward, as tip of finger indicate magnetic field direction at this center O position. So the magnetic field of DE and AB get cancel each other, and semicircle magnetic field mu 0 I upon 4R perpendicular to this plane indicated by direction of thumb when curled finger of right hand match curved current of circular loop, inward perpendicular to plane mu 0 I upon 4R. In this example also, observation position center of this circular ACD arc is not along the axis of AB or DE conductor, but it got R perpendicular distance at one end of infinite long current straight length. So all three straight AB, curved BCD, and again straight DE produce magnetic field at O. But as far as enclosure by current is concerned, circular arc produce clockwise enclosure, whereas straight portion produce anti-clockwise enclosure. So magnetic field of two straight length add together but is opposite to semicircle magnetic field, and semicircle magnetic field half of full circle magnetic contribution mu 0 I upon 4R become more than magnetic contribution of these two. One infinite conductor at end point produce mu 0 I upon 4 pi, so both will produce 2 times. Since magnetic field of semicircle is more than 2 infinite straight length, the resultant magnetic field, the difference, become mu 0 I upon 4 pi r multiplied by pi minus 2 Tesla. Let's check the same magnetic contribution of straight current sections when straight thumb of right hand is along current, then tip of curled finger at observation position indicate upward towards us magnetic field perpendicular to plane, and which is just opposite to magnetic contribution of semicircular coil, which is inward. So resultant is inward and difference. In this example, angle subtended by this semicircle BCD arc is pi radian, and if this angle is in place of pi radian become 2 radian as shown in this figure, then magnetic contribution of these two straight length perpendicular to plane towards us and magnetic field of this semicircle perpendicular to plane inward become equal and opposite, and resultant magnetic contribution of this configuration subtending 2 radian angle will become 0. Let us make a quick summary. In this first example, straight infinite length AB and D won't produce any magnetic field at this center O position of BCD semicircle, as AB length and DE length are coaxial to it. This magnetic contribution of semicircle become mu 0 I upon 4R. Similarly, in this example, AB straight conductor at R perpendicular distance produce a magnetic field in inward direction as produced by this BCD section, but DE section produce magnetic field in vertical upward direction equal to magnetic field of AB section, and magnetic contribution of straight AB section and DE section will neutralize each other, and resultant magnetic field is only of semicircle section at center point O mu 0 I upon 4R Tesla. Now in this third example, this AB straight length being coaxial won't produce any magnetic field, and magnetic field of semicircle BCD and straight infinite DE at one end add together, and resultant magnetic field will become pi plus 1 times of mu 0 I upon 4 pi r. In this example, all three contributor, straight AB, circular BCD and straight DE, produce magnetic field in the same direction as they make a single enclosure around observation position, and resultant magnetic field will become pi plus 2 times of mu 0 I upon 4 pi r. And in this last example, semicircle produce magnetic field in one direction and straight produce magnetic field in other direction, and resultant will become pi minus 2 times of mu 0 I upon 4 pi r. And if this angle of arc is only 2 radian, then resultant magnetic field will become 0. One can ask ratio of two magnetic field contribution, as this got a ratio of pi plus 1 is to pi minus 2. This example is a probable examination question. Two quarter circular section BCD and B',C',D' carry current from infinite long straight conductor AB, D and A dash, B dash and D dash, E dash as shown in figure, and we have to find out resultant magnetic field at the center of circular current sections. This straight green highlighted AB section and D dash, E dash section won't produce any magnetic field as observation position is coaxial to current length. Magnetic field of semicircle BCD section is perpendicular to plane inward, and of B dash, C dash, D dash is perpendicular to plane and upward. So two equal and opposite magnetic contribution will cancel each other. Similarly, magnetic field of straight section B infinite length endpoint mu 0 I upon 4 pi r is vertically inward, as tip of curled finger indicate here when thumb is in the direction of current. And magnetic field of A dash, B dash infinite length and point r distance same current I produce same amount of magnetic field, but tip of curled finger indicate that it is vertically upward towards us. So two magnetic field of straight length also cancel each other. So resultant magnetic field at center of this current configuration becomes 0. In this example, two straight infinite section AB and D dash E won't produce magnetic field on coaxial center position, but all other current contribution, this circular arc BCD and this D dash, C dash, B dash produce magnetic field of equal amount in the same direction. Similarly, DE magnetic contribution and A dash, B dash magnetic contribution form the same sort of enclosure. Magnetic field of both BCD circular section and D dash, C dash, B dash circular section is vertically downward to this plane as indicated by thumb of respective hand when finger of right hand are curled along the direction of current. And for straight length, when conductor is gripped in right hand thumb indicating direction of current, this tip of curled finger at observation position indicate inward direction, as this DE current produce magnetic field, tip of finger indicate vertically inward. So all contribution of two quarter circle, full circle magnetic field is mu 0 I upon 2r with I current and r radius, and quarter will produce 1/4 and two section add together become 2 times. Similarly, infinite conductor at end position produce mu 0 I upon 4 pi r magnetic field, and two conductor contribution A dash, B dash and D become twice of it, and if I take mu 0 I upon 2 pi r common, it become pi plus 1 times. So in a brief video of 24 minutes, we have explained different patterns of examination question. Now you can easily find out resultant magnetic field contributed by both straight conductor length and circular current carrying loops. Our other learning video of the same playlist are equally useful. You can use them in your studies and share them with your friends. And our video shorts are also equally useful in exam preparation. And if you need our online doubt clearing classes and dedicated exam centric notes, do join our membership. Thank you very much.